today is all about statistics. A lot of words, not a lot of math, so you really have no need for a calculator today. If you want to put them up, feel free to. This is a non-calculator day. A lot of words. Yeah, some of you guys like words better than numbers, and therefore some people really like statistics. The fact is, you're moving forward. Hey, what you got? You gonna fight? Yeah, stepping up. A lot of people, their senior year, in lieu of taking a pre-cal or even a bridge or bridge sales class, some people elect to take statistics because they're more wordy. They're more about reading and stuff. That's a good math to take if you're a reader, because that's what it's all kind of about. Only problem you run into is it's also about processing and attaching numbers to what you're reading. So it does have some of that. Today, not as much, but as we move forward, there are mathematical concepts behind statistics, obviously, because that's what you're doing. You're gathering numerical data, really. So anyways, that's what we're talking about today, talking about statistics. This is the introduction to that unit. It's a pretty short unit, it's only 4 lessons. So by the end of the week, we probably will have covered all of it, unless we get stuck on a day. All right, but today is not that day. We will not get stuck. We'll get through this, no problem whatsoever. All right, so let's go ahead and get started. Again, since there are so many different words, I'm gonna let you guys write some of these notes down before I really start talking about it. So here's the first page. Get it up. It's spinning and spinning. There we go. All right. Do I have video games? I have Sudoku. You know what that is?
Yes.
Isn't that a card game?
Huh?
Isn't that a card game?
No, Sudoku?
Yeah.
No. It's a numbers game. Huh? Yeah, I did. Thanks though for the reminder that Aiden didn't help out with. Plus, yeah. Some people just have to take over for his irresponsibility.
What is that?
I agree. He can't swim. He's bad at it. I don't even know what I'm saying though right now, so this is awkward.
No, I don't know.
You just made it awkward.
Do you know what it means?
Yeah. But it doesn't mean anything. Just something funny upset. Like if you tell someone they look like they can't swim, like I know Aiden can actually swim,
Yeah, I can swim.
but I just tell him that you look like you can't.
If you say anything like that to a guy, they're like, I can't
Exactly.
do it.
I'll just tell him.
Yeah, but I can swim. That's the
You don't have to keep saying that. We get it.
See, he had to reassure it yet again. How they work. Down to the side.
It's a TikTok thing.
Is it?
I looked it up.
It's a social
I don't have
experience.
TikTok, so.
What? He said I looked it up. Why you look it up on TikTok? You like TikTok?
I didn't look it up on TikTok. I looked it up.
You just
And
kind
it
of told
says
yourself.
it refers to a social, hang on,
Experiment, like I just
a
said.
social game on TikTok in which a person tells their boyfriend that they look like they can't swim and film their reaction with the intent of baiting a defensive and confused response out of them.
It works though, because if you tell a guy they can't
And you are
do
being
something like
defensive,
that, they'll get all
you said it
offended.
twice.
I can't, but I can swim.
It's like nobody's doubting.
Maybe he's doubting himself.
Yeah, exactly.
Aiden, are you doubting yourself?
Yes.
so while you guys are finished writing this, I want you guys to answer a couple questions for me. What are some things that statistics are used for that you're aware of? Huh?
Election poll.
Election polls, for sure. What else?
Opinions.
Opinions. Yep. Like whether or not Coldplay's songs all sound the same.
Yeah.
They do sound so. Two.
What else are statistics used for? Big time, right? Sports is the one that kind of comes to my mind first. I mean, some of the statistics that come up in sports, you're like, who even has time to come up with those, right? You watch baseball, people get up to bat, they'll talk about the percentage of them hitting on the first pitch versus the third pitch, how they do against right-handed pitchers versus how they do on left-handed pitchers. I mean, statistics about how they batted in previous years at different locations. I mean, it's ridiculous, some of the statistics that they can come up with in sports, right? Ridiculous. What else, though? Are
Science.
statistics used for? Science, absolutely. I mean, so you name any science, there's statistics involved in it. Think businesses use statistics? I mean, absolutely. You want your product to do well, right? You want to sell your product. Well, statistics are very important. Okay. For example, and this is one I like to tell everybody because I don't know if y'all have ever heard of this before, but it was really kind of funny in my opinion. So Coca-Cola versus Pepsi-Cola, right? Big rivals. They've been rivals for years and years. Well, y'all don't even remember this. Your parents probably do, but there was a time where Pepsi created a drink called the Clear Pepsi. Anybody remember this? Clear Pepsi. I mean, it probably wasn't even in your lifetime that it happened. But Clear Pepsi was basically the same taste as normal Pepsi, but it was like a Sprite. It was clear, right? So Pepsi had this idea to do Clear Pepsi. And like a lot of times when you are testing something, you will go to a specific area and you will test your product in that area. So Pepsi did this. Coke got wind of it and thought, man, this is a stupid product. So they went into this area and they bought out all the Clear Pepsi. They bought it all out. As soon as it would hit the shelves, they would send somebody in and they would buy it all out. Why do you think that? Why do you think they did that?
So it doesn't get to the public?
Huh?
So it doesn't get to the public?
No, that's actually not why.
I think Pepsi's doing really good with the product.
Exactly. They wanted to convince Pepsi that they had a winner. That Clear Pepsi was going to be the next big thing. Because if Pepsi thought they had a winner, what did they do next?
They sell it worldwide.
Not even sell it. Before they sell it,
They start making it.
they mass produce it, right? They think they've got a winner. They mass produce it. Coca-Cola's back laughing because they know is Clear Pepsi going to make it. Do you guys drink Clear Pepsi today? You know why?
Don't drink Pepsi at all.
Because it didn't make it. Okay, it failed. So all of a sudden Pepsi had all this product that they had mass produced and it didn't work, right? So they obviously lost millions of dollars to that. Anyways, here's the point. When you do statistics, it's not important just to do them. You gotta do them correctly. So if you don't, something like that might happen, okay? So statistics are extremely important, and some of the terms that we're gonna talk about today will not only prove that they're important, but how we can, moving forward, how we can understand what kinds to use, when to use them in order to be successful. So statistics it's not just gathering data, it includes collecting it, analyzing it. Also, it's important that you interpret the data correctly and that you can explain it to other people and present it where it actually is something that's usable. Statistics are often conducted to collect data about a population. Now, when you think about the term population, what is a population? Okay, like for example, y'all remember when we did Census 2020 last year? Who was the census for? Who were they trying to get? They were trying to gather data for all what?
Voters.
Everybody who lived in the U.S., right? So what did a census mean? They were trying to catch as many people. They were trying to get as many people to fill out that census as possible. Why? Because you want to try to reach the entire population. Is it always feasible to reach an entire population? No, it's absolutely not. Okay, it's almost impossible to reach an entire population. Okay, it's time consuming, it costs a lot of money. So when you can't reach an entire population, you need to at least get a sample. And that sample has to be very careful, because if you get a sample, if you survey only a group of your population, you want to make sure and get a group of population that doesn't hurt your data, okay? That doesn't have what we call bias, okay? So therefore, in order to create or reach this population and get the best data that we can, we need to have at least a random sample in order for no biases to exist. Okay, think about this for a second. The important thing to note is when I'm unable to reach my entire population and I do this this random sample, I've got to make sure and understand at least who is my population, right? For example, let's take Hollister. Would Hollister need to have people who live in retirement homes taking a survey about their product? Why? Are retirement people the people that they want to sell Hollister clothing to? Who does Hollister want to sell to? Younger people, right? Teenagers probably. So who is their population? Younger people, okay? So that's who they want to reach with this as their population. This is what they want to reach when they are, conducting their, later we'll talk about these, their experiments, their different samples. They're going to try to reach those people who fit in their population. So it's important to understand that, okay? It's got to be a group that is actually defined as your population. And when you go out to them, since you can't reach them all, you got to get as good a random sample as possible. So here's some things that obviously could hurt your random sample, that could cause bias. Self-selected samples, and then also convenience samples. Self-selected. Have you guys ever been asked to take a survey? How many times have you just completely ignored it? Almost every time, right? There are two major categories of people who take self-selected surveys. People who say, oh yeah, here's a survey that they're asking me to take, I'm going to take it. Who are those two major populations that take self-selected surveys? When you're volunteering your own information, who are the two major people who respond to those? Huh?
Critics?
Critics, right? People who either hate your product, those are your critics, right? Who else? People who love your product, right? Those are the two main people who will respond in a self-selected sample. Now, if I'm only reaching people who love my product, or I'm only reaching people who hate my product, is that the only people I want to hear from? Huh? Of course not, okay? That would cause a bias. Now, is it good to hear from people who love your product? Is it good to hear from people who hate your product? Absolutely. You can't get better if you don't know what people hate, right? So those groups are very important, but you don't want just those people to respond, right? That's the problem with self-selected. The only people who volunteer information freely are people who probably either love you or they hate you. And those are both good categories, but you need more for it to be a good sample. Does that make sense? What about convenience? Convenience sample. How many times have you guys done this with your friends? I bet out of the next 5 people, they're gonna like what I say better than what you say. You know what I mean? Like, okay, we're having an argument about who's better, LeBron James or Michael Jordan. You say, next 5 people who walk in, we're gonna ask them and see who wins, right? Well, is that a good sample? What if the next 5 people who walk in are a group of friends? Why are they a group of friends?
Because they.
Common interest, right? They probably think a lot of the same things as each other. So is that a good sample to ask? No, because it's just too convenient. It's the next 5 people who walk in, right? And if you think about that, then obviously that could skew your data big time, because you could be potentially asking people who think the same way, all right? So anyways, you gotta be careful with self-selected, because they either reach generally people who love you or hate you, and then you gotta be careful with these convenience, because you might end up just catching people who have very similar personalities, okay? One of the best ways it was ever described to me was like, what if you were doing a survey about, timeliness to things, and you asked the first 5 people who arrived? Well, guess what? If they're the first 5, they're gonna think differently than the people who arrive at the end. You know what I'm saying? So you have to be careful with these convenience samples, because a lot of times, the people that come in at the same time might have similar ideas about things. So therefore, we want to create samples that have the least amount of bias as possible, and we can do that by having a really good representation of our population. Remember what I said about population? That's the group of people who are important to what you're selling, what you're doing. That's your population. We never want it to be a group that's underrepresented or a group that's overrepresented, okay? All right, so let's answer these couple questions right here. Administrators at your school want to know if more vegetarian items should be added to the lunch menu. Decide whether the sampling method could result in a biased sample. Explain the reason. All right, so what if I said, okay, I want to know if people want more vegetarian options in this cafeteria, so I'm going to ask every 10th student waiting in line to purchase lunch. Y'all see that as being a survey that could be biased or non-biased? Biased. Everybody agree? Okay, so maybe you all agree that it's biased, but maybe you don't know why. Somebody want to kind of talk about why it would possibly be biased to ask only one of 10 people who are in line to eat?
Because they're in line, like what if the line's for people who don't like vegetables? You know what I'm saying?
You hit the nail on the head,
Or they might know each other.
but your explanation at the end tailed off a little bit. You're asking people who are in line to eat. Have y'all been to the cafeteria? Does everyone get in line to eat?
No.
What do other people do?
Bring
They bring their own food. They bring their own lunch. Why might these people bring their own lunch?
Because they don't think there's enough vegetables.
Maybe they don't think there's enough healthy options in line. Maybe that has nothing to do with it. Here's the point. Are you asking any of those people who brought their own lunch? You're only asking people who are waiting in line to eat. You're not asking people who have brought their own lunch that day, right? So therefore, people who brought their own lunch, they're underrepresented. Does that make sense? We don't want to under or overrepresent anyone. I guess you could almost say that people who are buying lunch are overrepresented, or that people who brought lunch are underrepresented. Okay? I need an ED on there. Okay, look at the next one. What if I survey every 25th person who walks into the lunchroom that day? Biased or not biased? That's non-biased, okay? I'm not leaving anyone out if I do that, am I? The only thing that someone might say is, well, if there's only 400 people coming in, and you're doing every 25th, you might not get very many people. I mean, technically, if there's only 400 people walking in, you do every 25th, how many people are you catching? Yeah, you're catching 16 people. Is 16 a very good group out of 400? Probably not. But what if 10,000 people were walking in and you did every 25th? A little better, right? You see the point? A lot of your sample depends on the size. If I have 400 people walking into this cafeteria, every 25th might not be a good representation. But if I have 20,000 coming in, every 25th is going to be pretty solid probably. So that's something to consider as well. Okay, so there are these two things, two ideas that we need to talk about next called experiments versus observational studies. And a lot of times people might think they're the same, but they're absolutely not. Why? Because in an experiment, you're actually going to impose a treatment on a group in order to collect their data. You're still going to be observing them after you give them this treatment, but you are purposefully giving them the treatment. That's experiment. Observational study is you're just observing individuals and you're measuring whether variables, without controlling them yourselves, you're measuring, what effects that has on those individuals. So there's a big difference between an experiment where you're giving them the treatment and an observational where you're just watching to see if a specific thing changes, I guess, whether it changes what happens to them in the future. So there's a big difference between the two. So look at this one. It says, a researcher asked college students how many hours of sleep they get on average every night and examines whether the numbers of hours of sleep affect students' grades. Does that look like something that's more experimental or does it look more observational?
Observation.
Okay, we've heard both answers. How many people say experimental? Raise your hand.
Am I the only one?
How many people say observational? Raise your hand. Yeah, it is observational. Why? Why is it observational though?
Because they're not really the students.
Okay, they're observing, but remember, observation happens in both. Why is this one not experimental?
Is there no change?
No, not really. Well, kind of. There's, okay, am I forcing a group to only sleep 5 hours? Am I forcing a group to only sleep 6 hours? Am I forcing a group to only sleep 7 hours and then checking to see how it's changing their grades? No. See, I'm not causing a treatment in this situation. I'm just asking students, hey, how much sleep do you get? And then I'm looking at their grades and I'm trying to see if there's a correlation. You understand? If you're not causing the treatment, then it's not an experiment, it's observational. So here, he's just asking people how many hours of sleep they get and then seeing how it affects their grades. He's not causing that change, right? All right, next one. An employee of the parks department wants to know if paint that includes latex is more durable than paint without latex. She has 50 park benches painted with a paint that includes latex and 50 park benches painted with a paint that does not include latex. Is this one experiment or observational? Oh, definitely, right? What is the treatment? Huh? What's the experiment?
Like different types of things.
Different type of paint, right? One's latex, one's non-latex. That's the treatment. You are forcing this bench to be a latex bench and this one to be a non-latex bench, right? So it's definitely experiment. You're causing that treatment to happen. And therefore, when you step back from it, you're watching to see what happens to those benches. Now, here's my next question. Even within this particular experiment, could there be bias? Could there be bias in this experiment? What if I happen to go around to all the exterior benches and do those in latex, and all the interior and I did those with non-latex? Why might that cause a difference? In a park, what's generally on the outside?
Less shade.
Less shade, right? Less trees. But inside generally is more shade, more trees. Could that cause an issue with the latex versus non-latex? Why?
Because one's getting more sunlight.
Yeah, more sun, more direct wind, more direct rain. Could it cause a difference? So even within an experiment, you gotta be careful how you conduct it, right? So what might I do in order to have a real comparison of which one's better, latex versus non-latex?
Like 50% on this side of the park and 50% on
Okay, so you might divide it and say 50% in here, 50% in there. A lot of times, don't you see two park benches together? Right? Like you have one here, and then maybe on the other side of the trash can, you got another one there. You know what I'm saying? So maybe what you can do is paint one of those latex, one of them non-latex. Why? If they're sitting in the same spot, guess what? They're probably taking the same sun, wind, rain, people sitting on it, skaters, jumping them with their skateboards and whatever happens on park benches. The point is, you have to even be careful within experiments or biases can occur. So that kind of takes us to the next page. Turn over to the back. And it says, in order for the data that's collected in an experiment to be useful, the experiment must be carefully designed. Your goal in a controlled experiment is to have two groups that are studied and they're under identical conditions with the exception of that one variable. So for example, those park benches. You want those park benches to be under the same physical toil, right? But one difference. One's latex, one's non-latex. That's the one thing that you're controlling, and everything else technically should be the same. Okay? Sun, rain, wind, people, and therefore you can really be able to determine whether latex or non-latex would have been more efficient. Does that make sense? So you're trying to control as many of the conditions as possible with the exception of that one change, that one variable that you've changed. You want the other ones to be the same. So the group under ordinary conditions, that's called the control group. But the one that's subjected to that treatment, that's called the treatment group. Okay? Pretty simple. In a randomized comparative experiment, individuals are randomly assigned to the control group and to the treatment group. Okay? And then on top of that, if the experiment is not a randomized comparative experiment, it may be subjected to bias and therefore it may not be valid. Okay? Y'all know what valid means, right? That you can trust the data. So a lot of times, if you're not real careful with your experiment, you can't trust the data. Remember Pepsi Cola? Maybe they should have thought of that. Maybe it would have been hard to think of that. But either way, they didn't maybe test it in enough locations, or at least they didn't outsmart Coca-Cola, and therefore that data ended up not being valid, and it cost them millions of dollars. So anyways, let's go ahead and try to answer these last couple questions, and hopefully you understand this. So first, we're going to talk about whether or not it's comparative, randomized experiment, and then if it is, we're going to see whether or not what the treatment is, who the treatment group is, and who the control group is. So first of all, here it is, a Faster website. To test the redesign of its website, an online bookseller assembles 96 users of the site and randomly divided them into two groups. One group used the new website to make an online purchase, and one group used the old website to do the same transaction. Users of the new site were able to complete purchase 22% faster. All right, so here's my question. Is this a randomized comparative experiment? Is it a randomized comparative experiment? What do y'all think? Yes, it absolutely is. What in the writing told me that it was a randomized comparative experiment? They were randomly divided, right? We don't know how he randomly divided the group, but it says, and we have to trust, that he randomly divided the group. Okay, so in this particular thing, what was the treatment? In this particular example, what was the treatment? What were they testing? Huh? The new website, right? The treatment was the new website. They were trying to see if this new website was what? It was faster. So who's my treatment group then? Who's my treatment group? If the treatment was the new website, who's my treatment group? The people, the users of the new website. Then who was my control group? Who was my control group then? Huh? I hear somebody say something. If my treatment group are the ones who tried the new website, who's my control group? The old website, the users of the old website. Because they're trying to see if the new one is better, if it's faster. So my treatment is the new website. The treatment group then are the ones who are using the new website. The control group's the ones that are using the old website. Does that make sense? Now here's the deal. Sometimes you just can't do an experiment. Sometimes you have to use an observational study. Why? Sometimes to do an experiment it's just not practical, or even it's not ethical. Okay? It's not ethical. How many of you guys have ever been whitewater rafting before? How many of you guys have ever bungee jumped before? You have bungee jump? What do you have to do before you do something dangerous like that? You have to sign a waiver. What does a waiver say?
If you
You
die,
get
it's not
hurt,
your
it's not their
fault.
fault.
If I die, it's not my fault, right? It's not this company's fault. I can't, nobody in my family can sue these people. All right, here's the point. Sometimes experiments they could cross lines, right? And because they could cross lines of not being practical, not being ethical, we can't do experiments, right? You have to do, instead, an observational study. Like, for example, when they come up with new drugs for cancer for people, what are these people who are going to test this product, what do they have to do? They have to sign waivers, right? Same thing. It would be unethical for them to just take people who are struggling with cancer and just say, hey, we're going to sneak this new drug on these people and the old drug on these other people, right? That would be wrong. So there's just sometimes where you can't do an experiment without the knowledge, right? Without the knowledge of it. So you have to do an observational study instead. Okay, here's the point. We want to be able to determine whether or not in these cases it would be smarter or better to do an observational study versus an experiment. So here's the first one. You want to study the effects of smoking on lung function. Is that better as an experiment or is that better as an observational study? Absolutely. Guys, how would this look as an experiment? You're going to start forcing someone to smoke just to see if it affects their lungs? Does that sound ethical at all? Then obviously that is not going to be an experiment that we can conduct. So that has to be a what? Observational study, right? No doubt about it. Because there's harm in that. And if there's harm in it and you're causing that harm, that is way out of the comfort zone, okay? Number two though, you want to know if people who consume 1,000 milligrams of vitamin C each day as a dietary supplement have lower cholesterol levels than people who do not. Could that be something that would be an experiment or observational study?
Experiment?
Sure, it could be experiment. Why?
Because people already take it.
Because what?
No, 'cause
What'd
it's
you
not-
say, Aiden?
People already take it. I don't know.
No, not really, because experiment, you're forcing that treatment, right? What'd you say?
Not really harmful.
Yeah, it's not harmful at all. Guys, 1,000 milligrams of vitamin C is not harmful at all. Vitamin C is a good thing. So that's why you can do this as an experiment, because you're not giving someone, you're not forcing a treatment on someone that could harm them. Does that make sense? There's a difference between causing someone to smoke to see how it affects their lungs than giving someone 1,000 milligrams of vitamin C to see if it helps their cholesterol. You understand what I'm saying? That's the difference of when I can use an observational study and when I can use an experiment. The last one people struggle with a little bit for a couple of reasons. One, you know, or you want to know if cats that are fed a diet of only canned soft feed experience more dental disease than cats that are fed a diet of only dry or hard food. Would that be better as an experiment or an observational study? Observational study? Does everybody agree with that? Yes, that's true. And here's why in a case like that. What's the end result all about? Dental disease. Right, if there's a question that one of them causes more dental disease than the other, because the result is something like that, is it really right to do an experiment on that? No. But if these owners give their cats that are the same breed as these owners who give their cats different feeds, is it okay to observe whether more dental disease happens with hard food versus dry food? Absolutely fine to observe that. But to cause that might be questionable because you don't want even animals to have dental disease, right? Some people, because it's cats, they say, oh, we can do an experiment on that. But if you put humans in the same situation, not the same, is it? So you have to kind of sometimes step back from things and just think from a little bit more of a, what's right versus what's wrong standpoint. Some people struggle with that sometimes, but in this case, because the result is getting more dental disease, you don't want to force that, so you'd rather just observe it. Does that make sense?
What if you don't?
What if you don't like cats?
No.
Because I don't like cats.
I mean,
I think they're evil. Huh? No, I think they're evil. I don't think they're.
Evil.
I think they, by nature, are predatory. I think by nature they're independent. They don't care if you're there. They don't like you.
Have you ever had a cat?
Yeah.
I personally, we have a cat, and my son likes it. I don't.
Well, I think you have a bias towards your cat.
Yeah, because the cat doesn't like you.
No, my cat's actually not even a bad cat. I just don't think cats are friendly just for no reason. I don't think if you call a cat, they come to you. I think they make
Mine
it.
do.
Not every time, I guarantee.
Not every time.
I guarantee they
I
don't.
train my cat to open the door.
If-
I think it'll come to
If you had a dog, do you have a dog?
Mhm.
If I, being a random person, walk in your house and I call the dog over to me, will he come?
No.
Lies.
No, no.
He will.
He won't even come for me. And I'm
Well, that you got a mixed up home then, because most of the time dogs, they're friendly by nature, and cats are evil by nature, unfriendly by nature.
I think it's a mix. It's the mix. I think that some cats can be really nice, some dogs can be really mean. Just a mix.
Go with most though. Are most
Most
cats,
is a strong word though.
are most cats friendly by nature?
all the cats.
Are most cats friendly?
You're both biased, so this conversation doesn't even matter.
Are most cats friendly? I just want an answer.
You,
what kind of question is that?
yeah, like how are
How
we
does
supposed to
someone
know?
answer?
Look
It's
it up.
really like mouth. People that like mouth like dogs.
What?
That is fact. It's true.
No, because my son, he likes Matt, and he
Your
loves
son
that
is just
cat.
really smart. Well, that's just an outlier. Your son doesn't count.
Why?
Because he's smart. He's like the genius of everything.
He is a genius, but that is not the point. The point is, cats don't generally come when you call. They don't really care if you're around them. That's why you can leave a cat all day, and they don't care.
Is a cat?
But dogs, they miss you.
Huh? Double.
All of them, 1 through 8, same problems.
Is it, were cats called man's best friend?
No, dogs are. Yeah. And why are dogs called man's best friend? Because they're just better.